right, welcome back. We are now going to continue on to the unit review for Unit 8. We are on problem 11, 12, and 13. Keep in mind that some of these problems are repeat, so much as like you might have on one page problem 12 and the next page problem 12. It's just the way that the problems were selected in your textbook. So basically the videos that I'm posting on the YouTube channel are in order. So as long as you're just going from left to right, or whenever it starts with problem 1 in the introduction video, just click the next video and it will go in order. So we're looking at this problem, these two problems, problem 11, 12, and 13. It wants us to classify each triangle as acute, equiangular, obtuse, or right. So essentially, these are four different types of triangles. An acute triangle, basically all the angles in the triangle are less than 90 degrees. Okay? Equiangular, if you have an equiangular triangle, it means that all of the angles in the triangle are the same, and the only solution would be every angle is going to be 60 degrees. Obtuse, the angles are going to be, at least one angle is going to be greater than 90 degrees. And a right angle, you're going to have one angle that's equal to 90 degrees. So this is the stuff that we're going to be looking at, the specific qualifications that will classify it as acute, equiangular, obtuse, or right. So we're looking at triangle ADB. Well, if we look, ADB is right here. We have an angle of 35 degrees, 120, and 25. Since we have an angle that is greater than 90, and this angle right here at angle D is 120 degrees, we are going to say that triangle ADB is obtuse. And that's because we have a angle right here in triangle ADB being greater than 90. Okay, so now we're going to look at triangle BCD. Well, let's look at it. BCD. The first thing that I want you to notice is we have this little symbol right here. As we've discussed many times in the classroom, that this symbol is a right angle symbol. So whenever you see this little like square in a corner of a triangle, it means that it's a 90-degree angle. So since we have a 90-degree angle right there, that's going to be a right triangle. Now, the last portion or the last question says we want to know triangle A, B, C. Well, if we look again, triangle A, B, and C are right here. We have right here another right angle that's formed. So since we have a right angle, triangle ABC is also going to be right. Okay, so now I'm going to move on to the next problems, which are number 17 on the next page. It wants you to find the measurement of angle 1. Problem 18 wants you to find the measurement of angle 2. And problem 19 wants you to find the measurement of angle 3. And I am going to draw the problem right here. So we have this cool looking shape. Kind of looks like a bow tie. So we have 35 degrees right here. We have 75 degrees right here. Angle 1. We also have angle 2 right here. Angle 3 and 28. degrees. Okay, so essentially what we're going to do is we want to find angle 1. So angle 1 is right here in this triangle. So I'm going to look at this triangle. We have a triangle for angle 1 that looks like this. It's 35 degrees, angle 1, and 75. Well, we know based on the properties of triangles that every 3 angles, when you add them together in a triangle, equals 180 degrees. So what we're going to do is angle 1 is going to equal 180 degrees minus these 2 angles. So we're going to subtract 35 degrees and 75 degrees. And that's going to give us 180 minus 35 minus 75. That equals 70. So angle 1 equals 70 degrees. All right. Now we're going to do the next problem. So angle 2 is right here. Notice how angle 1 and angle 2, they form a supplementary angle or a straight line. So since we have a straight line right here that's formed off of angle 1 and angle 2, and we know that angle 2 from the last problem, angle 1 is equal to 70 degrees. In order to find angle 2, we're going to take 180 degrees because this angle that's formed off a straight line that I just showed you right here, essentially it's going to be equal to, for angle 2, 180 degrees minus 70 degrees because we're taking the measurement of angle 1, and when we subtract 70 from 180, that equals 110 degrees. So the measurement of angle 2 is 110 degrees. All right. So we have 110 degrees right here, and then we have 70 degrees right here. All right, now we need to find the measurement of angle 3. It's just going to take a couple steps. We know that we have to find this angle right here. We don't know what it is, but since angle 2 is equal to 110 degrees, we could take 180 and subtract 110, and that's going to give us 70 degrees. Because these 2 angles right here, angle 2 and this angle, form a supplementary angle, which is equal to 180 degrees. All right, so now what we're going to do is just take 180 degrees, subtract 28, and subtract 70 to get the measurement at angle 3. So it's going to be 180 degrees minus 28 degrees minus 70 degrees. So that's going to be 180 minus 98 degrees, which is going to be 82 degrees. So the measurement at angle 3 is 82 degrees. So I'm going to give you a second to see the board completed, and then I'm going to erase it so that we can move on to the next problems. All right, so we're going to keep moving on. Okay, so moving on to the next problems. The next problems for number 8 and 9. Sorry, let me move on. Okay, so we are on problem 21 and 22. So for number 21, we have this shape right here. A, D, C, B. So it's this quadrilateral. And at A, it has two of those angle measures, those congruencies. At D, it has one. C, it has three. And B, it has 3, 4. And then we're going to have three congruency statements right here. This congruency statement for DC. We have 2 right there for BC and 1 at AB. And then we're going to also label H right there, J, F, and G. H has 3, J has 1, and F has 2, and G has 4. All right, so the problem wants you to show that the polygons are congruent by identifying all congruent corresponding parts. Then write a congruency statement. So if we look, we're just going to do matching now. Essentially, we're going to say angle A is congruent to, well, angle A has 2 of these angle marks. So we're going to move over to the other quadrilateral and look to see which angle has the corresponding 2 angle marks, and that's F. F has 2. So that means that angle F and angle A are congruent. Then we go to angle B. Angle B has 4 of these angle marks, and we go over and look, angle G has the same thing. So there's 4 right there, 4 at G. So angle B is congruent to angle G. So then we're going to go angle C. Notice how there's 3 marks right here. So then we go over to the other side, and it looks like H has 3 angle marks right there. Okay, and lastly, we have angle D, and it has 1 congruency mark, and we look and J has the other one. So we know that these angles correspond to each other, but we're not done yet. We have to match the corresponding sides. So I'm going to look at side AD. Notice how it has 4 hash marks. We're going to go over here and look at how JF has 4 hash marks.